So what we're going to be doing is we're going to be using normal CDF in order to find these. Remember, you need a graphing calculator or Desmos. How normal CDF works is it's always our least value and then our greatest value. And that's whenever we have a z-score. So in this first case, when z is greater than negative 0.58, what we're going to do is we're going to put our normal CDF, we're going to put our negative 0.58, and then what we do is we pick a large number, like 100. When we do that, what we get is a probability or an area of 0.719. Now, if we're looking at this next one, notice it's less than. So when we use the normal CDF, it's going to be negative 100, comma, the 2.1. And the reason that it's negative is because it's going to the left. So we need to think of a really large negative number. And when we do that, what we get is a probability that is equal to 0.982. And our last one, I think, is the easiest because we have two boundary points. So it makes it easy to understand which goes first and which goes second. So when we use our normal CDF, we're going to go 1, comma 2. And that right there is going to give us a probability or an area of 0.136. So that's how we find probabilities with a z-score. Now what we're going to do is we're going to look when instead of a z, what we have is an x. So notice that an IQ above 120. So that would be x is greater than 120. Now, in order to convert it into a probability, what we need to do is we need to use our formula. Z equals x minus the mean divided by the standard deviation. So we're taking our x value and we're converting it into a z value using the formula. So we're going to take our 120, which is our x value. It tells us our mean is 100 and our standard deviation is 10. So that gives us z is greater than, that would be 20 over 10, which is 2. So we're going to go use our normal CDF. And we put 2, comma 100. And that right there gives us a probability or an area of 0.023. Now, if we're looking at letter B, it's below 95. So that means less than 95. Once again, we're going to convert it into a z. We take our x value, we subtract the mean, and we divide it by the standard deviation. That right there gives us a z value of negative 0.5. So we're going to be using our normal CDF. We're going to do negative 100, comma negative 0.5. And that right there gives us a probability of 0.309. Now, for our last one, notice that it's in between these two values. So that means that our x value is in between 90 and 105. So we need to convert it into a z value. We use the formula again. 90 minus the mean divided by the standard deviation. We go 105 minus the mean divided by the standard deviation. So now we get 90 minus 100, which is negative 10, divided by 10 is negative 1. And we're going to take 105 minus 100, which is 5, divided by 10 is 0.5. We're going to use our normal CDF, and we have negative 1, comma 0.5. And that right there, when we use our calculator, gives us a probability of 0.539.